Hi everybody, I'm Kamal Takodra and I'm joined by Timmy Reddy Gadkul, who's from our development team. I'm going to be presenting about DHCP Relay on the 6200 today. So we're going to do a bit of an overview initially. I'm going to do a configuration refresh and actually what would be interesting in the feedback, this is obviously something we're obligated to tell you in the TOIs because it's a new feature, but it's an age-old feature that we're going over that's really a fundamental bread and butter part of the toolkit in any network effectively. So anyway, we're going to do a refresher around what the configuration is for using the relay function on CX. Then I'll go into a bit of troubleshooting. Again, that's a refresher as well. What commands are available. And then finally, I'll be doing a bit of a demo and hopefully it's keeps a bit of interest going there really. So let's dive in. So I think there was a lot of demand for this. So we've now got DHCP Relay enabled on the 6200 as of 10.06. Just really bringing feature parity for this feature, and there really was an ask around that. So in terms of what it supports both IPv4 and v6. It says here v4 is a default mechanism. So what that really means is that if you're going to use v4 out of the box, it's just a matter of putting the relay command on. But if you're going to be using v6, then you have to explicitly enable that globally. So I guess this really gives a bit more flexibility and competitiveness to this product in terms of where it's positioned. So if we look today at 10.5, if you've got 6200 and you've got clients at the edge wanting an IP address assignment, you're forced to actually go up to the layer 3 to another device. So the boundary is somewhere else, so you've trunked up, and there's nothing wrong with that, and that's really a valid configuration and it's got a checkbox. But today what we can do now is we can bring the relay function down to the edge effectively, and any clients wanting an IP address assignment can therefore get it directly onto the layer 3 boundary and unicast, send the broadcast as a unicast up to the relay where they want it. So again, up post 10.06, and again valid, and both these use cases are valid. So there are some slight caveats around this on the 6200. So the one right now is that when if you're going to be using v6, we're not currently supporting a multicast helper address over here. So you just have to be cognizant of that. If your customer's using v6 and they want a multicast helper, currently it's not available. It's under investigation, so it's not a no right now. It's something that's definitely under investigation, and you'll hear more if it is going to be available on the final release. Okay. Another important thing to remember is when you're using option 82 for effectively assigning some sort of information for the DHCP server. So typically it's the client MAC maybe, but we default replace that with the switch MAC. But when we're using snooping, that is automatically switched on, and it takes precedence over when you're using DHCP Relay. So snooping option 82 takes precedence over any option 82 that may have been configured when you've got a relay function. Other things to remember, obviously, we've only got a single VRF usable effectively. You still have the management VRF, no routing on a port for this product, only SVI. So your uplink will be a transit SVI. There is no DHCP server, so be very clear about, we've got Relay but not DHCP, and there's no multicast routing. So if you're going for this scenario where you've got layer 3 at the edge and you want multicast routing, you have to move. You can't do that. We don't support PIM or anything like that. So you're going to have to go to this function and have a layer 2 scenario. Okay. So let's go into a bit of a configuration refresher. Very simply, if you want to have IP helpers on, it's just directly under the VLAN. We support 8 IPv4 helpers under any VLAN, so that's quite simple. If you're going to use v6, remember you need to enable that globally first, and then put your helpers under the VLAN. And this just shows a basic stateful configuration where you're going to use DHCP Relay to assign your v6 addresses. We support, again, 6 helper addresses underneath the VLAN. But remember, we only support unicast at this moment and no support for multicast. Again, 8 helper addresses. And then if you're in the scenario where you're using like a dual stack, then you just basically same scenario, except that we support 8 of each under each VLAN. So let's go into a bit of troubleshooting, and really new to the 6200 are these commands. So there's a few set of relay commands that you'll be familiar with that are already on the CX platform, both for v4 and for v6. So let's dig into some of those. Really, the most basic thing is when you just want to do a bit of a quick view. You want to see, is my DHCP relay enabled? Have I got any options configured? And I've got some statistics here because pretty much captured from a live config. Now, if you're running DHCP v6, all that you get is effectively it's enabled, and then you get, if you've got any options, well, only option 79. So if you're running a dual stack and you want the MAC address of that client to be provided to the DHCP server for any debugging or anything like that, then in a dual stack scenario, you might enable that. So you can do a show IP helper address to see what helpers are configured under that specific VLAN. Same for v6. You can see what v6 helpers are under that VLAN. You will see here there's an egress port, which is really defunct at the moment, which is only used when you're using the multicast helper. And obviously that's just a remnant of what's left over from a code cutover. So you can actually look at all of the previous commands by doing a sub command. So you can do a show tech DHCP relay, and you can see all the previous commands. So you can see what I showed earlier, the enablement, what options are available, all of the statistics and all the helpers. And the good thing about this, you can see all of the helpers that are configured under all of the VLANs rather than the specific VLAN. Same drill with v6. Again, the same, sorry, this is a diag dump. So with a diagnostic dump, you can see a bit more information about what's configured and enabled. This does need a bit of a cleanup, really. There's some information here that's, from a bit of test code, but you can see the UDP port here. And you can see some statistics, and you can see that we've got some option 82 configured, and this is actually when we're using some snooping, basically. Is there anything else here? Same drill for v6. Again, needs a bit of a cleanup here. This is early code, but very sort of similar information available. You've got some statistics. You've got some snooping stats as well. which you can see actually in some of the Snoop commands as well. So you can do some dedicated Snoop commands that if you want to see some of the Snoop statistics, this just shows it in the relay dump. So you can see it elsewhere if you weren't going to do a relay dump. Okay, and there's the classic debug. You can do both a V6 debug and a V4 debug, where you can see effectively the packet walk and you see what's happening in terms of a client and a server, and I'll show you that in the demo as well. I've got a demo set up, and this slide you can use as a bit of a reference. So on the right here, I've got the actual configuration that I've got in the demo set up. We've got a Windows 10 client on the right, and we're going to do a bit of V6 to maybe make it a bit more interesting. And we've got a couple of APs that are going to do V4, and we're going to introduce a bit of V4 snooping. So we're going to do some quick view show commands. We'll do V6 assignment on the Windows 10 client. We'll do a bit of a Wireshark and a trace, and show some debugs on the V6 relay. And then we'll show some Snoop information when we get assignment from the APs. Okay. Actually, if you do download the slide deck, and it's in this, and it's not in a PDF format, and I don't know if it is, Ruben, but there's an actual video of the demo as well.
This demo is going to be showing DHCP Relay in operation on the AOS-CX 6200. Prior to 10.06, this feature was not enabled on this specific platform. Let's dig into the setup. We have a Windows client which is going to be trying to assign a IPv6 address through the 6200 relay, and on the left we have two Aruba APs on VLAN 112 going to be assigned IPv4 addresses. We have two uplinks and they're SVI transit VLANs. One's VLAN 111 and one's VLAN 110. VLAN 110 also supports V6. Our DHCP server is a couple of hops away, actually on the 8400 3003 for ::1 for V6 and 10.69.253.3 for V4. So first thing we're going to do is check what we've got running in terms of V4 and V6 on the 6200. So we had some show commands that I was talked about earlier. So the first one of those, which is our go-to, is the show DHCP Relay, and this basically tells us, are we enabled for DHCP in some of the options and some of the valid requests and responses. I've had this going in the lab for a while, so we've got some increments on the statistics here. We can do a similar thing for DHCP V6. However, all it tells us here is it enabled and do we have any options configured, and we don't. So we're enabled for both, so we're good to go in terms of that. We can also check our helper addresses too. So for V4 we were on VLAN 112, so we're going to check that, yes, and when we do that check we can see we've got the correct helper address that we're expecting. And then similarly we can do the same show command for V6 on VLAN 116 as I mentioned earlier, and yep, we have got our helper address configured to the server of 03::1. We can also do a type of what I call an all-in-one command, which is a show tech of the DHCP relay in V4, which gives us everything effectively that we looked at earlier. Tells us we're enabled, what options, shows us some of the statistics in terms of packets. We see what VLANs are enabled for what helpers, and we see if we're configured for boot P as well. Again, we can do something similar for V6 as well. So let's give that a quick run too. Okay, similar sort of drill. We're seeing it's enabled, and we're seeing what helpers that we've got configured. Also VLAN 117, I've got some helpers configured, but we're not using that for this demo. We can also do a diagnostics dump. The diagnostics really show some similar stuff in terms of what we've seen already. So let's have a look at the V6 diagnostics. And so this is an early code release that I've got here in the lab. So it's not as clean as it should be, and there's a cleanup operation going on. So we've got some VLANs that aren't even using V6 that tend to appear like VLAN 114. Here you'll see some stats. Obviously I've got nothing at the moment because I've got nothing happening. We can do a similar diagnostic dump for V4. We get a bit more information here. Let's have a look. Our VLAN 112, which just went off the screen. Again, we've got some client statistics and server statistics, and whether we're going snooping. I think we need to clean up in here. I think these have been pretty static for a while. We'll do a double check on that. And then let's have a look at debug, what we're running. In terms of debug, I've got a V6 relay and a V4 snooping. So let's go across and see what we can do in terms of V6. So I've got this is the Windows 10 client, which is connected to the 6200. So if I do a pconfig, we've got only a V4 address on this device, and this is how I'm hopping onto it. It's got 2 NICs on it. The other NIC is connected to the 6200. There's nothing configured on that at all. It's disabled, so I'm going to enable it now, and then I'm going to start a Wireshark trace on this too. So that's alive, and we're just doing a filter on V6. So I'll get some solicit addresses. So it's looking for, it's a multicast out on that local link. If I do an ipconfig now, we've got a local link address. Okay. So we still don't have a DHCP derived IPv6 address. We're still sending solicits out from the client. So if I do a show run current context, now we're hanging off of this VLAN, which I've shut down because I wanted to first of all show you that the client isn't able to achieve address, and it gets a local link address, and to run Wireshark and get some captures before everything happens, I needed to do that. So I'm going to open up the interface. We should shortly see a V6 address appear. Okay, I think that's happened already. So remember, we've got nothing, we've only got the link local. Now I have got a V6 address, and in fact I've got some DNS servers as well. So that's worked. Now we can see the V6 advertisement that's come through. It's captured on the wire. I can't remember, these were these solicits. If I scroll up, we can, there we are, just looking at the we've got a V6, DHCP V6 filter on, so we've seen that, and there we are. Here's the address 30018 that we've achieved here, and we should see DNS as well, DNS name server as well, that we've got in that DHCP V6 packet. There we are. And now if we look across to the switch, just to line all that up, just show debug buffer pipe to include relay. I think that should all we get there anyway, but yeah, we can see the packet. So we can see a packet received on B11.06 from client ending 3CAD. If I look for 3CAD, we can see that's that link local address here, so it's definitely from this device. And we see the packet walk effectively. So sent to server, received back, received on interface from client, then we sent to the server from client, received on interface from client, and the cycle goes on. So effectively we demonstrated obviously that we got the V6 address here, and then here's the trace of that effectively on the switch as well. So you can debug that too. So I also wanted to show another thing, and it's around snooping. But what I'm going to do first, before I talk about it, I just want to kick off these APs, so I can talk about it. So the APs were in port 117. So I'll power up the first one and power up the second one. And this is the first one. Let's just, yeah, that seems to be booting. Or not. Yeah, it's booting. Okay, so let me just quickly go across this diagram while it's booting. So prior to 10.6, when you enabled DHCP snooping, you didn't have a relay, and you would trust the uplinks here were pointing towards a server, wherever it may have been in the layer 3 network. However, in this scenario, and what would happen is that DHCP snooping would punt packets onto trusted ports up to the relays, which weren't on the switch. However, in this scenario where the relay prior to 10.6, if you make this configuration, what will happen is that the DHCP snooping will you'll see a drop occur, or a packet not going to a trusted port, because on that VLAN we don't have a trusted port because we're relying on the relay locally. So it will then get punted to the relay, and then we'll be able to achieve an IPv4 address. However, you will see some difference in the statistics. So let me show that to you. So I'm just having a quick look at this AP where it's got, okay, so conveniently we're just at the we've obtained a DHCP v4 address. So that's great. So we're in that state. So now if I do a show DHCP v4 Snoop, that's it. Okay, so the first thing that we see, so this is the VLAN we're interested. Well, we've configured it on 3 VLANs, but VLAN 1112 is what I'm interested in. So in VLAN 1112 is where it's client side. These are the servers I've binding, not binding to, these are authorized servers effectively, who are allowed to give me a IP address. Now 117, 118 aren't trusted ports, but they've got a dynamic binding, so they've got allocated an address. However, if I look at the statistics, you can see that I've actually got some forwarded from trusted ports. Okay, fine, expect that. But I've also got some drops, okay, occurring. And the reason I've got those drops is because of the phenomenon I explained to you earlier, is that we don't have anything on that VLAN that's trusted because we're relying on the relay. So you will see this incremented. So I'll talk a bit more about that, but we'll also see that in the DDub. So if I do a show debug buffer, I include Snoop, we should see that drop event occurring. Let's have a quick look. Packet. Okay, here we are. So I've client request packet received on port 118. So that's where the AP is, but also the packet was not re-forwarded, reason not trusted, no trusted ports to send. So that's what's incrementing that counter. We'll also see that for port 117. So packet received, discover packet received on port on VLAN 117. Packet was not re-forwarded, reason not trusted ports to send. So basically that's incrementing the counter, but what's actually happening is as follows. It's the request is going out, it gets punted out, it sees there's nothing in its layer 2 domain, and then it's not forwarded, but the relay picks that up, forwards it as unicast, and goes and finds the server. So there is going to be some sort of cleanup and adjustment to that, I think, in the future. There is a plan around that, because this was early code. I just wanted to make sure that it doesn't confuse anyone, and actually it's a good way of explaining some of that. So basically, in summary, I've shown you DHCP Relay on both V6 and V4, and we also showed a bit of snooping going on and what can happen between a layer 2 and a layer 3 setup, which is slightly different. Okay, so I hope that was useful to you. Thank you very much.